Good afternoon, my home at school friends. Today we're going to talk about sound and do some fun sound experiments. I used this book again to get some ideas. Last time we used it when we were talking about water. Before you can understand sound, you have to understand how your ears work. After all, what goes on inside your ears is what allows you to hear. Everything you hear is created by sound waves. For example, when a person talks, the movement of their mouth creates moving waves of air. These sound waves travel into your ear canal and hit your eardrum. This causes the ossicles to vibrate. These small bones are called the malleus, the incus, and the stapes. They are also known as the hammer, the anvil, and the stirrup. The vibrating ossicles transmit the sound waves to the cochlea. The cochlea contains small cells called hair cells that convert sound waves into signals. The signals then get to your brain, and that's what allows you to hear someone's voice. What are sound waves? As you learned, you hear when your ear processes sound waves produced by an object. The object produces waves by vibrating. When an object vibrates, it pushes against surrounding air. The vibrations cause the air to expand, called refraction, and compress. This causes areas of high and low pressure as the sound moves towards your ears in the form of waves. Wavelength determines the sound's frequency. Wavelength is the distance between waves. A long wavelength is a low pitch, and a short one is a high pitch. Amplitude determines the loudness of a sound, and it refers to the wave's size or height. Do you think loud sounds are large or small amplitudes? Let's find out. When I speak into the microphone loudly, you'll notice the amplitude is pretty big. When I speak into it quietly, it's smaller. So I have a ukulele here to show you amplitude. If I pluck the string hard, it's going to be louder. If I pluck it soft, it's going to be quieter because I use more energy when I pluck loud, and I use less energy when I pluck soft. So now that you know how sound works, we're going to do a few sound experiments. Our first activity will be to learn about amplitude. Remember, amplitude describes the intensity of vibrations or how loud something is. So what you're going to need for this project is a plastic cup, a push pin or something pointy, 16 to 20 inches of string, a paper clip, a paper towel that's slightly damp. So you're going to use a push pin or something sharp to poke a hole in the bottom of the cup, large enough to fit the string through it. When your string is mostly through the cup, you're going to tie a paper clip to the end of it so that it doesn't go all the way through when you're doing your little noise experiment. Let's make a prediction. Will the string make a loud or soft sound? Will it be a low or a high pitched sound? I'm going to take my wet paper towel that's a little bit damp, and I'm going to pull it along the string to see what kind of sound I get. I don't know. It's kind of a weird sound. I'm sure your mom and dad will love that. Maybe you can sing a song. When I pull the wet paper towel on the string, it's a pretty loud noise, and I was really surprised about that. If I used a dry paper towel, what do you think the noise is going to be just as loud or quieter? You can try that at home. So why does the string make such a loud sound? When you pull the string, you cause the string to vibrate. If the string weren't attached to the cup, the vibrations would be so quiet you wouldn't be able to hear them. Let's try that on a little piece of string without the cup. So I have a piece of string here. If I pull it, it makes a little bit of a noise, but it's not quite as loud. The cup acts like an amplifier. It's making the string louder. Playing a xylophone is like playing a drum. Drums and xylophones are percussion instruments. A percussion instrument is one that makes sound by hitting or scraping it. There's a big difference between the two. A xylophone is like a bunch of little different smaller percussion instruments, and each part plays a different role. We have a special video today. Lennon is going to demonstrate a real xylophone for us and talk about the sound it makes.
Hello, my name is Lennon, and I'm a musician here at Northwest High School. Today, I'm here to tell you why a note up here sounds different than a note down here. And why that matters in the xylophone that you are making. A xylophone is made up of varying lengths of wooden bars, all having the same thickness but having a different length. Each one makes a distinct sound depending on the length of the bar. It is played by using rubber mallets such as these. Now that we have a basic understanding, it's time to explain the way that the bars produce sound and how that works on your own xylophone. The explanation is quite simple. Being the longer the note piece, the longer the sound waves are, which look a little bit like this. Much like a roller coaster. The shorter the note, the shorter the sound waves are. So imagine the sound wave that I just made. Take that, just scrunch it down. And that's what causes the notes up here to end a lot faster than one down here. Because that takes a little bit to kind of finish up. But the shorter the distance from each note, like let's say one down here to one right here, it is less obvious to know how far apart they are. Now, I'll play a short song to give you an idea of what happens when all this comes together to make music. That's all from me. Thank you for listening. I hope you learned something from me today.
So what you're going to need to make your own xylophone are 3 jars. They need to be the exact same size, the same height, and you'll want lids, some water, food coloring in 5 different colors, and a wooden pencil. So I went ahead and filled my water bottles. The first one's going to go all the way up to the top almost. And then the next one will be a little bit lower, and so on until you get down to about here. I'm going to gently tap the pencil against the tops or the sides of the jars. Think about how each sound is different. As I go down, the sound gets higher and higher the less water there is. Why are the sounds different? When you tap the glass, the vibrations in the glass pass into water. The amount of water in each glass affects the sound that's produced. The deepest sound comes from the glass with the most water. This is because the water makes the glass heavier, so it's harder for the glass walls to vibrate. The sound generated is slower, so it has a lower frequency. Remember, the frequency of the waves determines the pitch or how high or low a sound is. Will the sound change if you use different liquid or a metal spoon? You can look for more sound experiments on the internet or check out the book I used. Thanks for joining us. Hope to see you next time.